In this video, I'll show you how to publish live temperature and humidity data from a DHT sensor using MQTT. These values will be displayed on mobile MQTT dashboard at the end of this video. We'll be setting up the entire project from scratch using ESP-IDF framework in VS Code. This project is the continuation of the previous video where we have learned how to read temperature and humidity values from DHT11 sensor. If you haven't watched it yet, I would highly recommend you to watch it first from the top right corner or in the description before proceeding with the video. Now let's get started with this tutorial. It requires same hardware setup as of previous video, and we'll directly get into the VS Code and do the configuration setup for this project. In the slide, you can see the setup of the hardware is similar. So here we'll be using MQTT protocol to send temperature and humidity values to the mobile dashboard. And here we can see temperature and humidity values being shown on the dashboard. Let's try to open VS Code. So after opening VS Code, click on ESP-IDF Explorer and you can see this ESP-IDF welcome page. So you can click on new project. So it will ask for the IDF to use. So you can click on it and here you can mention DHT11 MQTT publisher. So remaining all you can keep it as it is. You can use your board what you are trying to use and the board version, and here you can select the COM port and click on the template. Under ESP-IDF, select the sample project and create project using template. And you can see the project has been created and you can click on yes to open in a new window. So I'll close the old window and here I'll need to check in the main, click on main.c, you can see it is empty. So here I'll paste my code. Before explaining about the code, first we'll try to do the setup of this project. So again you can see dht.h might not be available. So you need to go back and open the terminal. So you need to run this idf add-dependency line and then press F1 and search for reconfigure task so that it will reconfigure. So in the meanwhile, I'll try to explain the code for you. So here you might have seen some additional directives and libraries that we are using. So first one, you can see string for string manipulation, ESP, Wi-Fi, events, NVS. So this NVS is nothing but non-volatile storage. Because we are going to use this Wi-Fi SSID and password, this has to be stored somewhere in the storage, right? That's why we use NVS flash. And then MQTT client.h is being used and dht.h. For dht.h, we have already utilized the component, and for MQTT client, we don't have to utilize external, and because this ESP-IDF already has this MQTT client.h. To check that, you can go back to the SDK, click on SDK configuration editor, and here you would be able to see something called ESP MQTT configuration. And make sure you enable 3.1.1, and if you are also using 5.0, you can enable it and click on save. So next you need to replace your Wi-Fi SSID and password, then you need to use your broker. So I'm using this broker.emqx.io. So that will be available here. So if you search for this EMQX, so it will provide you a broker, and we are going to use this with the default 1883. That's why I have used only MQTT and not used S, which means secure. And we are defining the 4 GPIO pin. And then here tag we have used DHT publisher, and so we have created a Wi-Fi event group so that once the Wi-Fi is connected, then only we'll try to connect to MQTT broker. And this is the MQTT event handler. So here we'll find MQTT client is connected, how it is trying to publish. So you can see this is the topic that we are trying to publish, and this is only for the status. So we are trying to send that sensor is online and trying to send these values. And once it is disconnected, it will say this one. And here Wi-Fi event handler, you can see this is Wi-Fi connected, disconnected, whether it got IP address or not. So all those things are mentioned. This is the standard boilerplate code. Next, we initialize the Wi-Fi. So this is also a standard code. So next we have MQTT app start. So this MQTT app start will be having the initialization of MQTT client and also the registration of the event that MQTT any kind of messages are coming or not. Then it will start the client. Next we have a publisher task. In this task we directly read the values of DHT11 and try to publish using this function that we have seen previously, that is ESP-MQTT client publish. So that is the standard function, and we are trying to send with this topic, that is IoT Frontier ESP32 data. So we need to copy this and we are trying to send a JSON payload using this format, where we are trying to send the temperature, humidity in one of the JSON values. And finally you can see app main. Wi-Fi initialization is the first, and then it will try to get the Wi-Fi event group, whether first if it is Wi-Fi is connected, then only we'll get all the wait bits true and this will be completed. Once that is completed, we'll see Wi-Fi connection is establishing and we can start the MQTT client, so that it will avoid the race condition where first MQTT will be trying and Wi-Fi might not be connected. So that's why we have kept this code. Next we start this MQTT app start, so that MQTT app, that task that we have mentioned in the top, will be started, and also created this task to run in the background so that the publishing will keep on happening. So this is the code that we are going to run. So we'll use this build, flash and monitor at a time. So for this we need to first connect your USB of ESP32 to your laptop. While this is happening, I'll also open another MQTT client that is called MQTT cool client. So here this is a web client to test the publishing and subscribing mechanism. So here we'll be using subscribing mechanism. So here we are going to copy this broker and click on this configure, so that we can add a new broker, and remaining will be same. Save changes and click on connect. So now this is connected. I can subscribe to this topic. So from the code I can see this is the MQTT topic, and click on here subscribe. So now let's wait here. So code is built properly and it is asking for flashing. So I'll use UART and click on flash button or boot button, which is on the right side of ESP32, to start flashing. So now flashing is done. It will try to monitor. Here we can see the IP address is available, which means Wi-Fi connection is established and it is starting the MQTT client. And then we can see MQTT client is also connected and values are being read. We can see these values. So here also you can see the values. So first 27, 63. So now also I'll try to blow some air to this sensor. You can see new value, that is 75. The humidity got increased, and after another 10 seconds we might see another value, that is again 75. So we can see the real-time values being shown onto the MQTT client. So next thing is we'll create a dashboard in our mobile application. So for that I'll try to connect my mobile Play Store. So you can also go to App Store and try to find this name, that is MQTT Dashboard Client. So install it and open it. So I'll try to clear it out. So this is the first home screen. So you need to first add the broker. So you can mention the name broker. URL would be smaller case, that is broker.emqx.io, and click on done. Now it has connected. So we need to create a widget. So here we have two options. One option is only one widget, or we can use two widgets or four widgets. So we have temperature and humidity values. So I'll create one widget, temperature and humidity, and the group name would be living room, and the widget parameter. So here you can give temperature first. The type we can put it as numeric, the icon temperature icon, and the broker it is already selected, QoS is selected, subscription topic. So we need to use IoT Frontier / ESP32 / data. Next we need to use this JSON parse data. So if you check the JSON, we are getting temperature and 27 as mentioned. So we need to use temperature. So it will use $.temperature to get the value, and remaining thing we can click on done. Second one also you need to add, and the same way you can use humidity, and here also numeric humidity logo, and again the same subscription you can copy paste, and here instead of temperature you need to put humidity and click on done. Now click on done. So immediately you can see the values of humidity and temperature values are being shown here, that is 27, 63. You can also cross check here 27, 63. Same way we can cross check here 27 and 63. I'll try to blow some air to see updated values. So after 10 seconds you might see some new value. Yeah, so after 10 seconds you can see 65 is the updated humidity because of the air blown. So this is how you can get the live temperature and humidity values from your ESP32 using ESP-IDF and VS Code. And that's it for today's video. If you found this video informative, please type helpful and smash that like button. You can watch more tutorials on ESP-IDF from this playlist. Your support means a lot to us and helps us keep creating more content like this. So please subscribe to the channel and hit the bell icon. Thank you for watching, and I'll see you in another interesting video.